So let's talk a little bit about a few methods for quantitative analysis of SDG interactions. There are a few nice studies out there, especially this one from Bennig, Weitz, and Carlson. And they try to kind of classify research on SDG interactions based on different aspects. So when you do SDG research, you have interaction entities, which means are you looking at goal-to-goal interactions, like SDG1 to SDG2 interactions? Are you looking at target-target interactions, indicator-indicator, or are you looking at interactions with externalities? Then also you have interaction qualifiers. So are you looking also at the direction? Are you looking at correlation, causality, direct links, indirect links? Are you doing a cross-sectional or longitudinal analysis? What data sources do you have? Obviously, we are now talking about quantitative analysis, so we are having databases or a model data. And then basically you have different analytical approaches. And obviously here we talk about statistical analysis. So if you're going to read a scientific paper on SDG interactions, you can try to use this kind of classification and see what the paper is about, basically. And then here is another approach to trying to classify SDG interaction papers. It's by Allen. And it's a different way of classifying, what the interlinkage is. Is it sectoral or siloed? Is it an integrated and indivisible approach? So basically looking at all the SDGs simultaneously, or am I looking at the siloed or sector, like the water, energy, food nexus? And then do I have a qualitative approach, a quantitative dynamic approach, quantitative static approach? So have a look at the papers if you want to and see, if you read something, where would the paper you're reading be classified into these different scenarios? What I will talk about briefly is correlation analysis, causality analysis, and briefly network and scenario analysis. So as you might know already, if you want to look at correlation analysis, the most well-known approach is the Pearson correlation coefficient. And in that case, it's for detecting linear dependencies. If you have something close to 1, obviously, you have a positive correlation. If you have something close to -1, you have a positive or perfect negative linear dependency. If the correlation coefficient is close to 0, it implies that there's no linear association, but it doesn't mean that X and Y are not related. It just means that Pearson is not able to detect anything. And you see, the different results and the figures of how figures looks like, or how correlation graphs look like based on the coefficient we have. And on the right side, you see a little bit the famous N-scope picture, or I don't know how's it called, but you can see that you have for all these 4 kind of different graphs, you have the same Pearson correlation coefficient, which is 0.8.2, but you actually see that just 1 or 2 you could identify as a linear dependency. So what's if there is not a linear dependency, but you have a nonlinear dependency? Well, then you need to move to another correlation coefficient, which in this case could be Spearman's rank correlation coefficient. And here it's similar to Pearson, as you might know, that in case you have something close to +1, you have a positive monotonic or nonlinear relationship, and the other way around with -1. And something close to 0 implies that there is probably no monotonic dependency, but it doesn't still mean that it's, not in relation to one another, X and Y. And then you can see already in the figure again, you have a linear trend, you have a monotonic trend, you have a graph where you have an outlier and how this is influencing the result of your correlation coefficient. And they're all kind of different scenarios on where you need to be really closely looking at the relation you have and what correlation coefficient you apply. Obviously, every coefficient has advantages and disadvantages that you need to be aware of statistically. And also it's depending, as I said again, on the data type you have and on the data quality you have. So if you have a data with a lot of outliers, you might think to improve the data quality. So what does it mean in case of SDGs? So how Praja might have, like Professor Pradhan I have introduced to you already. He is defining synergies and trade-offs based on the Spearman correlation coefficient between SDG indicators. And then he's summing and aggregating the results to the indicator and target level. So what does it mean? Well, it means that you're categorizing interactions as a synergy and trade-off based on correlation or anti-correlation between indicator pairs. And based on how the Spearman correlation coefficient ranks, so you're having certain intervals, you're classifying it as a synergy, a not classified interaction, or a trade-off. And what is also important is the direction of the indicator. So is it an indicator you want to increase, or is it an indicator you want to decrease? For example, maternal mortality rate, an indicator you want to decrease. Greenhouse gas emissions, something you want to decrease. But GDP growth, something you might want to increase. So you're giving an indicator also a sign, because it will define whether something is a synergy or a trade-off. So what does it mean now in case of, all the indicators and so on? So we discussed already that, you have the goals, you have the targets, you have the indicators, and then you have the sub-indicators, and you have disaggregated sub-indicators. So you're measuring the correlation at this disaggregated sub-indicator level. So I have, again, put this example I have introduced to you already for SDG 6. Indicator is 6.2.1. It's about the availability and sustainable management of water and sanitation. Then you have these 3 sub-indicators I have shown you about, the population with access to hand washing facilities. And then it's disaggregated into the population living in rural areas and the population living in urban areas. And then you could measure the correlation to an indicator related to SDG 1. So is like this in relation to, reducing poverty. And this is really the basis on how you measure a synergy or a trade-off. And then you can aggregate the results at the indicator level and then later on to the target and goal level if you want to. So, but what is if you don't have a linear or a nonlinear association, or you just don't know what association you have? Well, also here you have definitely several options out there. If you're moving to a relationship type that might be exponential, cubic, or it might be parabolic, or you just don't know. You can go for mutual information coefficient, for a Hoeffding D correlation coefficient. What I have used, for example, is the maximal correlation coefficient. And it has a strength of detecting linear or nonlinear associations in a 2-variable data set, because it has 2 heuristic properties. When first is that it implies that if you have a sufficient sample size, the statistics should observe both functional and non-functional relationships. And then the other one is equitability. So it intends that similar scores will be seen in relationships with similar noisy levels. So what does it really mean? We talked about Pearson correlation. So if you go to the, rainbow colory figure, which you see here with the A, you see every dot you can see is a relationship between A and B. And then you see the results for the Pearson correlation and the MIC score. So basically you have the scale for Pearson from 1 to -1. And if you know it's close to 1, you can assume it's linear relation. And if then the MIC score is also high, then well, it's a linear relationship. But if Pearson correlation is close to 0, so in the red area, and MIC score is also low, then it probably is randomly. So it's not really a dependency between the 2 variables. But if Pearson correlation is close to 0 and MIC score is high, you might know that the dependency is something nonlinear or non-monotonic. So please have a look at the different options out there, depending on what you want to look at, what correlation coefficient is suitable for the analysis you're doing, because everything has advantages and disadvantages. So I guess this figure you have seen quite a lot last day from Prajal about, having, these synergies and trade-offs for all these certain SDGs. And when you see on the left, I'm always giving you this classification. This is a really practical example of a scientific paper we have been doing. And always in the gray boxes, I'm putting you later if you want to have a look at the classification. So what are we looking at? what data was used and what statistical approach was used. So here it was about, detecting nonlinear dependencies. And just to give you here an example of what could be an SDG interaction that is nonlinear, well, you see the relationship between access to electricity and the internet use. And obviously, the sooner you have access to electricity, it will popping up the internet users you will have in a country. And you see this also is a really quite strong nonlinear relationship. Another one would be the under 5 mortality rate in relation to obentification, which is C. And also here you have a strong nonlinear relationship. Both are synergies, obviously. So another task I would give you is you have downloaded a few data. Maybe take 2 indicators and try to see, is this a synergy? Is this a trade-off? Try to, if you want to measure the Spearman correlation coefficient, see what the value is, whether you are able to classify it as a synergy or a trade-off, or just plot it in general and see how this is moving along. Maybe there's just no relationship between the 2 indicators you have. What I was referring to is also that correlation does not necessarily imply causality. And I have here an example I want to show you about a cause and effect relationship that is between actually chocolate consumption and Nobel Prize winners. And this paper claimed that really chocolate consumption enhances cognitive functions. And therefore, in certain countries, as Switzerland, for example, you will have more Nobel Prize winners. And then now you can question, does higher chocolate consumption really actually, manifest in higher cognitive functions or not? And is this a false correlation or not? And the question is really, is there a third variable that is influencing the relation or not? And obviously you have different options. So it could be that X is causing Y, like Y, or the other way around. It could be that, you have a common cause that is a third variable. It could also be that you have confounded or like causal effects of Y and X that are confounded by many factors, different factors. It could be an indirect effect, a direct effect. So you have all these kind of different causal links that you need to be potentially aware of. You have some kind of different options that are currently applied in the SDG context. And this is, for example, Granger causality and its transfer entropy. So both statistical methods can be used to, and let's not call it causality, so let's call it the direction of influence you can measure from a certain observation X to, another observation Y. And what you really need to be aware of are different statistical assumptions. So are you assuming your data or your interactions might be linear or nonlinear? Is your time series stationary or non-stationary? Do you check for unidirectional interactions, bidirectional interactions? Do you have time lags in the data that might be disturbing your statistical analysis? Do you have outliers, and so on and so on? So if you want to look at granular causality, there is a nice paper out there from Durgo et al. You can have a look at that. What we are working with is transfer entropy, and we are looking at the interactions of SDGs with the externality, which is the bioeconomy. So if you know, bioeconomy is kind of promising avenue for utilizing renewable biological resources to meet needs for food, energy, and materials. But bioeconomy is not sustainable by default. So it can mean that you have harming practices that are actually reducing environmental, or do have environmental impacts, and so on and so on. So you don't need to familiarize yourself with, just to give you an insights into what does it actually mean at the indicator level if we talk about causality analysis. So I have given you here 2 examples. So on the left side, which is A, you see a synergistic interactions, and on the right side, you see a trade-off interactions. A is for Sweden, B is for Spain. So let's dive deep into it. So you have an indicator that is land cover change in grasslands, and you have an indicator that is change in water use efficiency. So water use efficiency is a metric that measures the economic value generated per unit of water used. So you can see here that for Sweden, obviously land cover change of grasslands you want to increase, and also the change in water, or like the water use efficiency, you want to increase. So for A, Sweden, it's a synergy, as you can see, and for B, Spain, it's a trade-off. So generally, it was assumed that in Europe, in European grasslands, a significant increase in water use efficiency was observed, attributed to regulated transpiration and increased carbon assimilation. However, the figures show that this illustrates, it's really context specific. So really a difference or discrepancy between certain nations. So it is really necessary that we have a nuanced approach that acknowledge regional differences when we do certain assumptions. But if we talk about causality, so we see a strong correlation for both a positive and a negative correlation. And if you now go for the transfer and trophy measure, we want to know what indicator is driving the change and what indicator. And on the left side, in the panel below the graphs, you see the Shannon transfer and trophy results. So you see the direction, it's going from X to Y and from Y to X. And you see, the correlation, the transfer and trophy correlation value, you see the p-value and the significance. And therefore, based on the results, which you might calculate using a software program and so on, is it unidirectional, is it bidirectional, and what is driving the change in what? And obviously here, the land cover change indicator is driving the change in the water use efficiency indicator. One could say so that the bioeconomy is enhancing SDGs, or the bioeconomy is mitigating SDGs. So it's a really just a general or like a basic introduction for you to the topic of causality analysis. I know that, but just that there are certain calculations or statistical methods out there that are applied and are able to detect the direction of interactions moving beyond the correlation. What we also have is scenario analysis, obviously. So what is it? It's the process of forecasting the expected value of a performance indicator given a certain time period, occurrences of different situations and related changes in the values of system parameters. And then you will always have a certain baseline scenario. You will have alternative future scenarios that are, based on certain strategic approaches. This tree you see here, where you have the A1, A2, B1, and B2 scenarios, depending on different forces and where you want to focus your development on. So just to know that, different definitions of future scenarios are out there. And then you might know about, the representative concentration pathways, short RCPs, which represent different possible scenarios of greenhouse gas concentrations in the atmosphere for the future. So on the left, you see this kind of spaghetti diagrams, how they are called, about all these thousands of different scenarios on where our greenhouse gas emissions can go to. And quite, known are RCP 8.5, RCP 6, RCP 4.5, and RCP 2.6, which is actually also a net negative global emission scenario. And you can see on the right, currently all know we are already in 2024, how scenarios will move along and what will it mean for the temperature rise, what will it mean for extreme weather events, and so on and so on. So formally, RCP 8.5 means that an average increase will lead up to a temperature rise of 3.7 degrees. This will cause large extreme weather events. And as I said, an RCP 2.6 would even mean that we are decreasing our emissions to formally estimations. And then in combination to the RCPs, you often hear about SSPs. These are the shared socioeconomic pathways. You have your 5 scenarios projections up to 2100, and they focus also on exploring different social, economic, and technological factors that drive greenhouse gas emissions and climate change. So the figure shows you SSP1 is like the sustainability scenario, and then you have the middle of the road scenario, regional rivalry, inequality scenario, and fossil fuel development. And then you see also that, the greenhouse gas emission and global mean temperature will rise differently based on the scenario. So for SSP1, our mean temperature will remain the lowest, whereas if you project a scenario using the SSP5, our global mean temperature will rise the most. And then for the practical application, if you want to have a look at how are those scenarios used in the SDG context, there is a nice paper out there from Björn Zerger. So every time I'm referencing, papers, I have listed them at the end of the presentation, but also each time at the slides itself. So you can quite easily have a look at those if you want to. So basically, what the authors are doing is they are comparing sustainable development pathways and see how different SDGs are then accomplished or not. And you can see they have covered really all the SDGs. They have kind of grouped them into, planetary integrity SDGs, and then the provision of material needs. And then you see each of the scenario colors, how they're moving along into a gray box. So it's like a box of, do we achieve things or not? And you see like blue is like a combination of SSP and RCP scenarios. Like green is like SSP1 and the 1.5 degree scenario. So there are different combinations out there. I will not go much into detail, but basically also for the scenario analysis and SDG context, research is out there and you can have a look at this. So to conclude, some basic takeaway steps. Well, as I started with, the whole purpose of science is to find meaningful simplicity in the midst of disorderly complexity. And as you can see, SDGs are complex. You have tried to download a few indicators, but this doesn't mean you have looked at something holistically. It means you have a sectoral or siloed approach. And at the end of the day, whatever do, it is in the end also how you convey your findings, how you can be able to convey your findings, whatever you have, because formally, scientific results we have for 15 years, but have we tried to been able to convey our findings to different stakeholders, and whatever we do, for whom is it useful? So ask yourself not only about, what research design am I applying, what data am I using, what statistical analysis, but also how am I able to convey whatever I found? And is it somehow a meaningful simplicity for this complexity that I have tried to tackle? I just put you here three, because I started with figures, so I'm ending with figures, some nice examples on how people beyond the scientific community are trying to convey some sustainability issues. And you can see, for example, the fish at on the sand are actually created from discarded plastic bottles at the beach, which is kind of, ironic. And then there is in the middle, this is a painting from Banksy. I don't know if maybe some of you know them. He's a quite famous artist who around the world is painting art on public spaces, which are kind of provocative. So he's not talking about climate change. He's talking about political issues and other things. And for example, here is one of his paintings where he said, like, we are all on the same boat. And then on the right side is also a nice paper on SDGs, which is, summing it up again, that wherever sometimes you go, you will find something about SDGs, which is, I guess, a nice way